Hello guys, welcome to this video. In our last video I talked about everything you need to know concerning difflib. Like I said, it's a built-in Python library that you can use to compare two words together. But before we can do that, let's look at the traditional way we can compare two words together in Python programming language. We can use words basically this dash that actually equals to compare two words together. Okay, let's say I created a and say var1 and then I gave you, let's say, Ezee kit. Can I just give it Ezee kit? Like I can say var2. I can say Ezee kit. But let me put this E to be capital letter. So how can I compare this value var1? When I say var1, I'm talking about variable. I just a variable I gave it. You can put it anything you want. So I can use this comparison. I can say print var1 is it equals to false for me, because this guy, even though let me remove this, even though these two guys seem to be a little bit seem to be different in our own understanding, this capital letter E here is definitely since here is small, here is capital. This comparison operator cannot differentiate both of them. Cannot differentiate which one is which one is one. We're just trying to check whether, for example, 1 is equals to 1, 2 is equals to 2. So let me run this first. Let's get. You can see here I got, but even though we know that they seem exactly the same, but what happens when I move this and put a small letter? You can see I got true here. This is one of the basic way, or I can say the traditional way we can try to compare two words together. Okay, I can also say, I can also use n. This is basically going to say this var guy is in var2. Let's run it and see our output. You can see I got true. This method, this using this in is a little bit better compared to that of equals to, because in this scenario, let me move this guy, let me move this kit from that of var1. You can see I still got true, because why did I get true? Just trying to say this Ezee here is inside this entire Ezee this var2, which is Ezee kit, and since this Ezee here is also here, it's going to match. In the situation whereby I move this and so I move one E here, it's still going to match well. You can see I still got true, because this Ezee is inside this guy, which is this Ezee. See, and these are mainly two basically where we can compare words together. We can also use this when we want to compare what is it called? Compare a sequence of data. Like here is string. We can also compare lists together. But you can see that this tend to have a limitation, because when I put something like, when I move these Ezee keys and maybe I put something like 1 here, let's see what is going to happen. You can see I got false. Using it because when I said n, I'm going to check everything here is inside here. You can see this one here that appears here is going to be a problem when it comes to this of matching format. So this is where difflib comes in. Now next we are going to make use of difflib, so we can understand how this difflib works. How it can be if we are using difflib, these two values, these two this variable 1 that holds this data and this variable 2 that holds this data, when we compare both of them, we can see we'll be getting a close ratio of almost close to 99%, if not 100%. But in this situation, what we actually get here is just 0, because they are not they are not the same in anywhere. So what we did, we just compared Ezee keys and Ezee keys here, make use of the equals to and that of in to compare. There are still a whole lot of other ways we can do that, but in this we want us to talk about this, make use of this library we have been talking about all this, which is difflib. Well, like I said, difflib is a library we can use to compare words together or sequences of data. So it can be string, list, tuple, and a whole lot of them. And before we can make use of this, we need to import it. Like I said, it's a built-in Python library, so you don't need to install it. So how can we do that? I can say import of. You just basically, once you have this imported, so you just run your script to know whether it actually runs successfully. You can see I got to know this means I successfully imported it. In this video, I'm going to make use of one of the functions that of difflib library, you can say difflib module, which is called get close matches. So we're going to import difflib, but then from that of difflib we are going to import get close match. And how we can basically do this at an instant is just from this of our difflib. From this of our difflib, just like saying from this module, I want to import one of the function that is inside of it, which is our get close matches. This get close match is a function that is going to help us to get close match, and our item we are going to provide what is called an element, our target. We set our n to our default. N stands for number of output we want, and then our accuracy, which is also called a cutoff. So let's dive in. So the first we are going to do is to come down here. Let's create of our list of elements that we want to get the close matches on. So I can say elements, which is going to be this. I can say that I write something like apple here, grape. I can say orange. I can also write maybe something like apricot. Okay, I think let's make use of this. So I can say let me write the grape too. Let me come down here. Let me create my target. I can say target. My target is to get, let me write apple. I know that inside this of our element here, I have nothing like apple exist inside here, but I want to check inside this of our element here. I want to check which word is closely related to this. The highest, like I said, the one with the highest accuracy closely related to this of our apple. I'll know that it is apple. So we're expecting when we set n equals to 1, we're expecting to get apple, and setting reducing our accuracy, we can get our desired output. So I can say here I can make use of matches. What is the matches going to be? I can say get the close matches. The first thing we are going to write is our distance. Inside we are going to put our target. That is target we are interested in. The element we want to check to whether it exists inside of our element list or element items. So here is going to be our target, and here is going to be our which is going to hold our elements. So the next thing we want to write inside here is our n, to set our n. Let's say we set our n to be what? So we set our n right here. So we set our n to be what? Let's say we are interested in getting 3 outputs. Let me drag this up. We are interested in getting only 3 outputs. So also set our cutoff. Let's set our cutoff to 50%. I can say 0.5. This cutoff ranges from 0 to that of 1. 0 is 0% and 1 is 100%. And then when you are running 0.1, which is 10%, 0.2 20%, 0.3 30%. So this way we can set our accuracy. So down here we can print our. So when we print our match, because when we print our match, it's going to provide us with the element that has the best closely related. So let's run it and I will explain what is actually happening here. Let me click on it. You can see we're able to get apple, grape. Like we wrote grape 2 times. Yeah, sorry, I wrote grape 2 times. Okay, let me just write something like banana here. Banana. Yeah. So let me run the rep. We're able to get 2 outputs. Why did we get 2 outputs here? Because when we set this to 50%, only the closely related matches that as of 50% is only this of apple and grape. Other one, this guy orange does not even match. But what happened when we reduce the accuracy, which is this cutoff? Let's say I reduce it to something like 30%. Right now we're going to see more output on it because the accuracy has been reduced more to 30%. So let's run this. You can see I was able to get orange. Meanwhile, orange was not there yet. It was not there earlier. But to reduce it more and more, the more I'm reducing it, the more closely related matches I'm expecting to get. But this is not when in a real life scenario, your cutoff should never be below 50%. Setting it to 30%, 20%, you just want to bring yourself to a whole lot of error that you do not want. But let's say in a situation where we want to get only 1 output, because we're getting, let me drag this up. are getting 3 outputs here, the closely related match. And this, remember that this output has been sorted in the way they are best closely related. This output tend to be the highest, followed by this grape and this orange. So let me set this to 1, this n to 1, and remember that n is our output. Let me run it again. You can see I've got apple. If I set it to 2, which means setting apple and orange, let me drag this up. You can see we got apple and grape. So I set it to 3, it's going to be apple, grape and orange, like what we getting. So you can see how interesting this was to do, rather than using our traditional way to compare two words together or 2 sentences together. Make use of the and the comparison operator, and the comparison operator equals to operator to check whether they are the same, or whether some part of it, of this particular word, is in that of the other word target. So I think with this we don't need to do all those things. This get matches is going to basically go inside of this element and then try to find out which element that is inside there that matches of our target. Remember here, when you are writing anything inside, or when you are setting your elements inside here, make sure it's something that is in kind of a string format, so that I can check the length. If you put a number, it's going to be a problem, because number you can't check the length of one, it become a serious problem. But if you close it in the quote, it can be handled. So that's basically what I want us to look at in this, to make use of another function inside this of our difflib library. And what is that function? It's called ndiff. How does this function work? It compared to sequences line by line. We are going to see something like plus, we are going to see something like minus, we are going to see something like question mark in front of them. But I'm not going to explain what that does. When we do an example, we are going to basically see how it does, because explaining it is not going to do much. But when you see a minus in front, let me just give a quick overview. When you see a minus in front, it means that the element or the character is in the first sequence of data you want to search for. Let's say you have 2 variables, variable A and variable B, and the first one has something like easy keys on it, the second one easy keys 2. In the situation where we are trying to compare this, you can see that 2 is not in that of 1. In this situation, since they are, but let's just go and let's do example, so we'll see what we're talking about. Let me comment this out. So we have to import it from this difflib. I want to import that ndiff. So how can we make use of this? The first thing we are going to do is to create a variable. Let's say I create var1, then the first one I gave it, let me say hello watchers. Okay, second one is var2, I can say let me write hello Ezee kids. So I'm going to use this ndiff to compare both of them. So how can we do it? I can say print, so down to print this ndiff. It takes 2, the same is A and our B. The first one is going to be val, so ndiff. Inside you are going to put our 1 and then comma up 2. These are basically the 2 important parameters that we need to see. So let's run this and see out. You can see down here I get something kind of a gentle object. So for me to get the actual output, I can put a list here in front of it to convert it to, for me to get my actual output, because here this is a generator object that we made use of, that will got printed out for us. Also I can use dot join. So let me use the first one. Let's say list, got it to list. Let me run it. You can see the output that we got here. So something like hello got printed out here. Next we saw kind of a minus sign in front of this W, A, plus E, plus Z, plus E. What does this actually signify? It signifies that in this hello we have here, this signifies, since there's no any sign in front of it, that means it appears in that of variable 1 and that of this variable 2. You can see it appears on it, and you can see the next one you have here is minus W. This minus W signifies that this minus W is in variable 1 or is in our first matcher, but it does not appear in this of our second matcher. You can see something like minus A. You can see it appears here but doesn't appear here. But when we see plus, plus e. What does this plus e signify? Like it's opposite of that of minus. When we say plus, just assume it's as opposite. This e signifies that is this variable 2, but does not exist in this variable 1. Okay, so let's make use of this. Let's make use of join for us to examine this more carefully. So let's say I put something like the word join. I want it to be printed out in a new line, or let me just move this guy here. Let me run this again. Okay, look at this. You can see this hello. It appears in both of them since there's no sign on it. And the second one is minus w, meaning that it appears in this variable 1 but doesn't appear in this variable 2. Once you see minus in front, it means it appears on the first search but doesn't appear on the second search or the second sequence, as we can see here. But when we come here, we see something like this t. You can see this t here. It doesn't have any sign in front of it because this t here appears here and it also appears here. But we look up this, you can see our x2 doesn't have anything. When we see minus, because this is really important, because when we start making use of this, we're not going to get, so we won't get confused on how this works. Once we see minus in front of our word or what we want to use and search, it means that it's in that of the first word, is in that of our searcher, the first searcher or the first variable that we created that holds the value, but it's not in the second one. If it's plus, that means it's in the second one but doesn't exist in the first one. Like you can see plus k here. This plus k, when we look at it, there's k here but there's no k here. Plus signifies that it's in the second one, which is this variable 2, and it's not in the first one. Hope it's not confusing. One of the use case of this, when it comes to when you want to, maybe you want to plagiarism, for example, can use this scenario, can use this to detect plagiarism. In a situation whereby somebody try to tweak what you wrote earlier to modify his own, we can make use of this ndiff to find out the one that was being tweaked. Because if you check here now, this hello that appears on both of them, and then you can come down and get which one or which of the words or word characters that appear on that of your own that also appears on that person. So let's make a real life example. Let's say, so I wrote something like artificial what? Intelligence is the way forward. Okay, let's say artificial intelligence is the way forward. This is what I wrote on one of my article, and one guy from nowhere just want to copy it, but instead of modifying it to a better something that makes sense, he decided just to shorten this artificial intelligence to what? AI. But so now artificial intelligence stands for AI. So let's run this and see what's going to happen. When we look at this, say that this intelligence is what was being altered, that is what was being changed. But when is the way forward, you can see when we look at it, it still signifies that the person didn't change much of the thing that we wrote, but it was just only this artificial intelligence that was to that of AI. You can see plus I, you can see here plus I was here but was not here. So you can see this is one of the advantages of using this ndiff. There are a whole lot of other advantages, but you make use of this advantage where we write something a little bit bigger, because right now this is just trying to explain how it works, and there's nothing really much on it. So as we go on, we're still going to make use of this ndiff really well. Use of another class in this of our difflib module is called diff. I can say differ. And how do we import it? Because here we're actually inside this of our difflib, so I'm just going to import the class which is called differ. Yes, just differ. Simple as ABC. We're going to make use of a method inside of this differ. If you have not watched my video on classes, make sure to check it so you understand what when I'm talking about class and method. Method are just more like a function, and this more like a function. Yeah, and method has always been a class. So this differ is a class, and then I'm going to make use of the function that is on it. But we're not going to just explicitly create a variable to do that. What we'll call this differ, we'll just directly call the method under it. So let me comment this out. Okay, let me create two variables because we'll be trying to match two things together. Let's say var1 is going to be, let's say hello watchers. Let me create another one. Let me just copy this since they are closely related. Okay, so let me just say 2, and I can say hello. I can say hello Ezee kids. So let's make use of this. This differ works in similar way of this diff. They work in similar way. But how this differ of a guy works in this separate way, because when we did this ndiff, right? Where's our ndiff? So when we use this ndiff, we was able to go line by line, each character to check whether it appears on that of VR1, or can see variable 1 and that of variable 2. But how this guy works is just basically similar thing. But this is going to just to take a full lot of them. Making use of this diff. It works in similar way with this ndiff. There's no much different on it. Okay, let's try and make use of this ndiff. Let me remove this. Let's do the similar thing that we did here. Let me just copy this. Let me remove this and put it in. Let me comment this out. So here we're trying to check how many of our words that we wrote that got changed. So we're going to copy this too. We're going to do similar thing here. If I run this, we're still going to get our previous video. So let's wait for it to load up. You can see we're able to get this. Let me drag it up so we can see it well. Yeah, we're able to get this. Was the output that we got in our previous video. So how can then let's apply here? We make use of this ndiff. So let's apply difflib. So how we want to do it? We're going to call the difflib here. We can say difflib, which is called differ. And since it's a class, then we're going to call the method under it, which is compare. So they just basically with difflib, we'll call this difflib, and then dot compare. It's going to compare these two guys. So we're still going to get similar output. As you can see here, we got, let me draw this up more. You can see we still got the same similar output. So both of them basically doing the same thing. There's no much different, but I just want us to make use of them, this ndiff and this differ that will compare to see. You can use any one of your choices. It's still going to do similar things. This is one of the, you can see, class that's been on that is on this of our difflib. We are going to make use of the class which is called sequence matching. I can say sequence matcher. I see this sequence matcher as one of the best class that's being provided by this of our difflib model. So okay, so how can we import this? Since we're inside of this model, we can directly import it here. So I can say from difflib import get close match. Talked about get close match in the previous video. Ndiff, differ, and next one is what? Sequence. It's called sequence matcher. We're going to call some method inside it also, which is we are going to make use of that of ratio. They have other method, but we're more interested in that of ratio. Ratio is just to check, to give you the how closely the two output are, to a percentage of how closely the two output are. So let me come down here. Okay, let me just silence all these guys that we did previously. Let me come on top here. Let me just write it. Environment looks dirty, but it doesn't do much here since it's just tutorial on what basically do. So the first one to write is just let me create a variable 1, and then let me create Ezee kits. Let me write a data a value Ezee kits. Okay, let me write the second one, and the second one let me just write tech kits. So I'm going to, in these two, okay, this is variable 2, in this variable 1 and this variable 2, which has all these content or these values on them. I'm going to check, I'm going to use this sequential matcher here to check how closely related, how close these two values are as of these tech keys and that of Ezee keys and this of our tech keys. I want to check how closely both of them are related to. So I'm going to call this of our sequence. You have to start with capital letter. Sequence matcher. It takes mainly 3 parameters, which the first one is that of A. A is your first variable, B is your second variable. However, that thing is called is junk. Automatically, this junk is being set to none, so we don't need to bother about this. So let's put the what is this? Let me say A is equals to our variable 1, and then that of B is equals to our B is what the variable 2. So here we're done with this. Let's try printing out this guy. Let's see what we get. Let's say print. Let me run this. You can see down here we get kind of difflib sequential matcher object at clinical. So what we're going to do, we're going to check the ratio to see how closely these two guys are. We're going to, in this sequence, let me give this space. In this sequence class, we're going to call a method inside of it, which is called dot ratio. This ratio varies from 0 to that of 1. 0 means 0% and 1 means 100%. So let's do dot ratio. Dot ratio. So remember, it's a method, open and close braces. I can say open and close brackets. So let's run this and see how closely these two guys are to each other. You can see we get something like 0.66, meaning they are 66. I can say 67% closely related. Usually why they are 66% because of the way they are. This kit appears in these guys too, and this Ezee was really what was differ. So it's found out that both of them, they are closely related to each other with accuracy of 66, I can say 67%. But let's see in the situation, because if when we got this showing us 66%, so 0.66 is not look much interesting to us. Let's turn it to our real life understanding of percentage, how percentage was. So I'm going to times this by what? By 100. I times it by 100 is going to turn 0.66 times 100 should give us 66.66, which when we approximate should give us 70. We can see here 66.666. When we look at it, we can know that 6 can approximate to 66, which is going to be 67. So let's make here easy too. So here we'll be shortening this into be 100%. We can see we got 100%. So let me write something else. Let me write welcome to what Ezee is. Let me run it. You can see we're able to get 62% upon though all the things, there are other things were added to it, plus the spaces, the space bars that appeared here. We're able to get how many percent was that? That one should be 62%, as you can see here. I take it as my best in all of the classes and the function that has been provided by this difflib module. Because in a situation when we are doing web scraping, for example, we're going to make use of this. When we are doing arbitrage bet, we're going to make use of this sequential matcher to check maybe in a particular bookmaker, may say a match between Man U and Man City, and then Man U, some bookmaker might name it as Man United, while some might name it as Manchester United. So but with this sequential matcher, we can try to check how closely both of them are. So let's just make an example of them. Let's say Man United, and here we're going to look at Manchester United. Let me run this. You can see I was able to get 74%. Even though both of them doesn't look like they make sense the way they are. But any team, any side that I tend to write it in this way, any side I tend to write it in this way. If we were to set our threshold to be something like maybe 60%, this way we can confidently say that these are the two games. These are the two current games that we should have focuses on. So we're going to make use of this sequential matcher a whole lot more than other ones. I also going to make use of this get close too, but this sequential matcher tends to be the overall general for me, for my case, because I've made use of it. I've made use of all of them. Sequential matcher tend to be flexible a little bit more than other ones, and this get close to why this ndiff and differ doesn't really do much for me, unless in a situation I want to check how closely my tester or my PDF the way it's been, things that have been changed. There's a whole lot of real life example that's being used, but for me, the one I mainly use of this sequential matcher and get close matches, I'm going to make use of this very, very well. So I think we have come to the end of this video. I think in our next video I'm going to do a whole lot of other things relating to this difflib module. So I'll be happy to see you in the next video. Thank you for watching.